All right, so we have find 3 minus 5i divided by 7 minus 4i. Okay, so 3 minus 5i divided by 7 minus 4i. We're dividing two imaginary numbers or complex numbers. And we have a way about doing this. And the first step is fairly simple. It's just to remember that you're going to multiply the numerator and the denominator by the conjugate of the denominator. So 7 minus 4i is our denominator. The conjugate is 7 plus 4i. So you keep the respective numerical values the same, the 7 and the 4, but the sign in the middle changes, okay? So if it was negative, it turns to positive. If it's positive, it turns to negative. So that's what the conjugate of a imaginary number is. Basically, the middle sign in the middle changes to the opposite sign, but just the numerical values without looking at the sign, the 7 and the 4, the absolute value of those numbers stays the same. Okay, and we're going to do that to both the denominator and the numerator. And we'll multiply that because if we just did it to the denominator, you change the problem around. Okay. And let me go ahead and rewrite this as 3 minus 5i plus 4i over 7 minus 4. So I'm making it look a little neater. Now for the denominator, you could technically FOIL this out to find the result, and then adding all those like terms up. However, that's not necessary. The result after you FOIL is always equal to the square of the first plus the square of the second number. Okay, that always will occur. So you don't need to FOIL. All right. So 7 squared plus 4 squared, that'll give me a 49 plus 16, which is a 65. And so let me just write 49 and 16. Now for the numerator, we have to do a little more work. Here you have to actually FOIL. 3 times 7 is 21. 3 times 4i is 12i. Minus 5i times 7 is minus 35i. Minus 5i times minus 4i is minus 20i squared. So we get 21 plus 12i minus 35i, which makes a minus 23i. Okay, minus 20i squared. And I squared is negative 1. So that I squared, turns into a minus 1. So again, using the fact that I squared is negative 1, and this is a result from the definition of I, which is the square root of negative 1. So 20 times minus 1 is negative 20, with another negative makes it positive 20. So you get 41 minus 23i over 65 after adding the 21 and the 20. Now, a lot of people will stop here and they say, yeah, we're good. One last thing you have to do is you have to put each of the terms in the numerator over that one number on the denominator, the 65 in this case. Why? Because our final answer has to be in a plus bi form. Okay? And that is how you would go ahead and divide two complex numbers. Okay? Thank you for your time.